Hello, this is Mr. Collier, and today we're looking at continuous probability density functions. Okay, so we've seen one of these before with the normal distribution. If you look at the normal distribution graph, it looks like that, and it's a continuous probability distribution because it can take on any value. Let's use the example of IQ scores. The average IQ score is supposed to be about 100. I'll write that down here. And then within one standard deviation should be 115 and 85. Okay. Anyway, that's the normal distribution, and of course all the probabilities have to add up to 100% or 1. Okay, so in any continuous probability distribution, then the sum of the probabilities has to be 1. In other words, the integral from the beginning to the end has to be equal to 1. Okay, so they use that to solve a lot of problems. Also, the mode is defined as the maximum value. All right, so in this case, the mode would be 100. Okay, that's the maximum right there. But you can have different distributions that look sort of like, something like that, and then the mode would be just the maximum. So you would solve that graphically. Okay, most of these questions will be on the GDC section of the test. Median is, the median is also 100 for this distribution. It's the point at which 50% is above and below that point. So in this one here, I guess it would be probably somewhere like here would be the median. And you can calculate that by calculating when the integral is going to be equal to 0.5. Okay, you could be also asked for the lower quartile, so you'd have to do the same thing, but you have to get the integral equal to 0.25, and for the upper quartile, you'd do the integral equal to 0.75. Okay, the mean is, and these two formulas are in your formula booklet. The mean is defined as the integral of x times f of x, and the variance is defined as the integral of x squared times f of x minus your mean squared, which you calculate this way. Okay, those are in your formula booklet. If you want to get the probability from one point to another point, you get the integral. Like if you want to get the probability of a person randomly being selected having an IQ from 85 to 115, you do the integral from 85 to 115, and you can get that probability. Okay, and since the variance is omega squared, the standard deviation is, of course, the square root of the variance. Okay, so we're going to do some examples now. Okay, we have the first example. Continuous random variable x as a probability distribution function as shown. Okay, so this looks like this is half x, so this is what the graph's going to look like from 0 to 2. You got half x, looks something like that. Okay, that's the probability distribution function. And probability that x is greater than 1 is just going to be this area here, which is, the integral from 0 to 1, or 1 to 2, of f of x, which is half x dx, okay? You can easily calculate this without calculus, but let's use calculus. That's going to be, so that's going to be x squared over 4 evaluated from 1 to 2, which equals 2 squared over 4 minus 1 squared over 4, which is 1 minus a quarter, which is 3/4, okay, which makes sense. Okay, now aside, why is there no difference in probability of x greater than 1 and greater than or equal to 1? On a continuous probability distribution, effectively, the probability of getting one single value is 0, okay, so it doesn't matter. Like the area, this area here is pretty much equal to this area, not including that one point there, right? It's infinitesimally small. Okay, next question. Find k a constant in this continuous probability distribution function. And to do that, you can do the integral from 1 to 3 of kx squared dx has to be equal to 1. Okay, the whole distribution has to be equal to 1. So we do that integral, we get k, let's say 1/3 kx cubed, evaluated from 1 to 3 has to be equal to 1. Alright, in other words, k times 3 cubed minus k, actually could have brought the k out as well, times 1 cubed equals 3. I just multiplied both sides by 3. Okay, so this is 27k minus k equals 3. 26k equals 3, so k equals 3 over 26. Okay, next find the probability that x is less than 2. So we have to do the integral from 1 to 2 of, I'll put the k outside, of x squared, right? So that's 3 out of 26 times 1/3 x cubed evaluated from 1 to 2. And that equals, well, the 3's cancel, we got 1 out of 26 times 2 cubed minus 1 cubed, which equals, that's 7. So 7 out of 26. Okay, in this next example, we have another continuous probability distribution function. We're going to find the exact value of the median. And first we need to find this value of k. So we'll do the integral from 5 to 6 of this. Gives me 1, as it always does. And the integral is kx minus 5x plus half x squared, evaluated from 5 to 6 equals 1. And substitute that in, we get 6k minus 30 plus 18 minus 5k minus 25 plus 25 over 2 equals 1. And start simplifying, we get 6k minus 12 minus 5k plus 25 minus 25 over 2 equals 1. And then we get k plus 13 minus 25 over 2 equals 1. Let's multiply by 2. We get 2k plus 26 minus 25 equals 2. 2k plus 1 equals 2. 2k equals 1. So k equals half. Okay, so now to get the median, we do the integral from 5 up to, we'll call it m, I guess. Has to be equal to 0.5. So k is half. Okay, and that integral has to be equal to 0.5. So we'll work that out. We get half x minus 5x plus half x squared, evaluated from 5 to m, has to be equal to 0.5. And let's just plug everything in. We get half m, half m minus 5m plus half m squared minus, and we'll have plug in 5. We've got 5 over 2 minus 25 plus 25 over 2 equals 0.5. And there we're going to get negative 9 over 2m plus half m squared minus 5 over 2 plus 25 minus 25 over 2. And let's multiply everything by 2. That'll make it much easier. Negative 9m plus m squared minus 5 plus 50 minus 25 equals 1. And looks like a quadratic. So I'll put m squared first. Minus 9m. This is plus 20 equals 1. So then we have m squared minus 9m plus 19 equals 0. Okay, this doesn't factorize, so we'll need to use quadratic formula. So we have m equals 9 plus or minus root 81 minus 4ac, which is minus 76 over 2. So we have 9 plus or minus root 5 over 2. But remember, we're just looking at x between 5 and 6. So if we have 9 plus root 5 over 2, that's about 9 plus 2 over 2, or about 5.5. If you do the other one, that's about 9 minus 2 over 2, which is 4 or 3.5. So it's not this one. Okay, so our answer, our mode, or our median is 9 plus root 5 over 2. In the next example, we got another continuous probability distribution function, and you got to find the expected value and the variance. Okay, so the expected value, these formulas are in your booklet. The expected value is the integral from -1 to 1 of x times absolute value of 3 times 1 minus x squared over 4. Okay, and let's use our GDC for that. Okay, so math 9, and we got -1 to 1 of x times the absolute value, which is over here, of 3 times 1 minus x squared over 4, and dx, of course. And we get 0. Okay, so I guess it's a symmetric distribution, just like the normal distribution, I suppose. So that happens, you get 0, and the variance will not be 0. That can never be 0. So the variance is just the same integral, so I'm going to pop up and click enter on it. And it's the same integral with an x squared in it, then minus 0 squared. Okay, so I'm going to insert a squared. Oh no, that's the wrong side. Delete, delete. Here I'll insert an x squared. There we go. Press enter. And we get 0.2. So the variance is equal to the integral of x squared f of x minus the expected value squared, which is just 0, so we don't have to worry about it in this case. So when we did that integral, we got 0.2. So the variance is 0.2 on this one.